We will be starting in a minute. I'll just make sure that everyone has logged in. But welcome, everyone. Okay, I think we're ready to begin. Welcome to Scandburg WebAcademy. This is the second of 2 webinars that we have been hosting on improving breeding performance and research results by controlling cage humidity. And today, Stuart Newman and Karen Egelund Petersen, that's myself, will be presenting. We will present ourselves a little bit in a few slides. So first of all, I would like to welcome you, as I already have done, and then I would like to tell you a bit about the background for us doing these webinars and also the agenda for today. The background is the current pandemic, the COVID-19 pandemic, and us not being able to go to conferences and meetings as we had planned. So we would like to present our data to you in another way, and the webinar was then, of course, a good choice for this. Today, as I mentioned, Stuart Newman and myself, Karen Egelund Petersen, will present ourselves. And then I will give you a very short summary from the last webinar we did a week ago. Then I will present a study on breeding performance that we have been doing together with King's College London. Stuart will be presenting a study on embryo transfer, also done at King's College. And then I will shortly give some perspectives and I will round off the webinar. If you have any questions, you can write them in the chat and we will take all questions at the end. As this is a short webinar, we can do it like that. The webinar is recorded and you will receive the recording in an email afterwards. And then, as I have mentioned one time, I think a few people joined in after, please turn off your microphones and your cameras. This is the best way to lower the risk of us having issues with the connection to the internet. My name is Karen Egelund Petersen. I'm a veterinarian by training and I have a PhD in vivo pharmacology. And here at Scandburg, I'm employed as the scientific affairs manager. That means that I'm responsible for the studies on relative humidity and the effect of research animals that we're doing. And I'm also responsible for our Scandburg Academy, which this WebAcademy is also a part of. And then, Stuart, I will give over the word to you shortly to introduce yourself.
Perfect. So yeah, hi, I'm Stuart Newman. I currently manage the mouse program for a veterinary therapeutics company called Pet Medics. Previously, I worked at King's College London, where I set up the genome editing and embryology core. And before that, I worked at the Wellcome Trust Sanger Institute as an animal technician and then as a transgenic technologist for about 7 years. And before that, I graduated the University of Bristol with a zoology degree. So yeah, that's a quick introduction to me, and I'll hand back over to Karen.
Great, thank you very much, Stuart. But as promised, just a short summary from the last webinar. some of you have joined, and those of you who haven't joined the last webinar but would like the recording, you can always contact us, and then you can receive the recording by email, and it will also be available on our website within a short period of time. This webinar was an introduction to the concept of humidification on cage level, and also how we can make this accurate control of relative humidity in the cage possible. And at the last, what we discussed at the last webinar is a unit, air handling unit called the ScanClimb, that can humidify air in IVC cages and also in cabinets like scantainers. It works like a normal air handling unit, but it can also humidify the air, and some units can also dehumidify the air. And it can be done quite accurately with a relative humidity accuracy of ±3%. And as we had this unit, we wanted to investigate how the effect of reducing this non-systemic variation of relative humidity in studies, the effect on research animals, and also the effect on study results. And we have had a focus on the normal physiology of the animals, looking into the breeding performance of the animals. We have been looking into the literature on how relative humidity can affect research animals, and we have also done various studies ourselves. We have been comparing controlled to uncontrolled relative humidity, so the controlled relative humidity in the cages to the sometimes very uncontrolled relative humidity on room level. And we're also very interested in looking into how fluctuations in relative humidity can affect our research animals and our research results as well. Last time I presented a study where we have seen an effect on water intake of mice. Here we saw that controlling the relative humidity at various levels within the regulatory guidelines actually led to the mice drinking significantly less when compared to relative humidity controlled at room level. And this is perhaps not surprising if the animals are subjected to lower relative humidity, but it could be a quite important thing to take into account if you make studies where thirst is a motivator, for example, in behavioral studies, or in studies where you are measuring water intake of mice. Then I presented some of the studies on breeding performance of mice and rats the last time. We have significant data on an improvement in breeding performance of mice and an indication of an improved breeding performance in rats. Of course, this could be interesting to look further into. Today, we will be discussing more data on breeding performance of mice. For example, Stuart, as I mentioned, will present the embryo transfer data that we have been collecting. The last time I also presented how we could see a tendency to a lower aggression in male mice by controlling the relative humidity. This is a study that is still ongoing, but it's very promising data that we could lower the aggression in male mice, which could have a huge impact on the welfare of laboratory animals, and of course also on study results by reducing the number of male mice taken out of studies due to aggressive behavior. Then we are also very interested in looking into specific areas of research. We are doing some studies or study at the moment on how the respiratory tract and the respiratory system can be affected by controlling relative humidity, but we are also very interested in looking into, for example, cancer research, metabolism, behavior, and so on, doing a dedicated research project with a postdoc or a research assistant to perform this study. So we have seen a lot of promising data and also some indications that laboratory animal science needs better control of relative humidity. Today, as I mentioned, I will be presenting data from King's College, and I would like just to start out by introducing you to the background of them having the ScanClimb system. They wanted to establish an animal holding area outside their main biologic services unit, and this area didn't have a proper humidification control. So they installed the ScanClimb. And of course, when introducing new systems or new equipment into a facility, there were some concerns how it was the working environment going to be for the staff when the humidity wasn't controlled as highly on room level. How was the liability and the compliance of this equipment? After the installation, they did measurements on how the fluctuations were in relative humidity in the cages. They saw a low fluctuation, this plus minus 3%, as I mentioned. And they also they compared it to the higher fluctuation in room level. They had an ability to collect the data easily when they had audits, collect the relative humidity data easily, and they had a reliable system that they found easy to use. So this was just the initial test to the use of the ScanClimb at King's College. And they also installed the unit in an alternate light cycle facility that they started. But today I will be focusing on a study that we did on how the tight control of relative humidity improves the breeding performance of mice. And this was done as a retrospective analysis. So I will be presenting the aim, the design, and the results of the study, and I will also be introducing what limitations we saw in the study. And lastly, I will conclude on the data that we found. The aim of the study was to investigate the effect of controlling relative humidity on breeding performance of mice, and we would compare the room control relative humidity to the control relative humidity on cage level using the ScanClimb system. And the study design was a quite simple design, comparing two groups of mice. This was mice of various backgrounds. It was the breeding in the facility that we collected data from. And group one was the cage control relative humidity, where we had a control relative humidity above 55%. I stayed above here because this was the units that were not dehumidifying the air, so we could keep a lower level steady in this group. And we compared it to the second group where the relative humidity was controlled on room level. And we collected data we looked at data from 8 months, from January to August. So we had both cold and warmer periods. And we looked into parameters, the parameters pups per litter, pre-weaning mortality, and total litter loss. And during the period, 2,600 litters were born. As I mentioned, the study was focusing on comparing built-in humidification with cage-based humidification. This was in 2 different rooms. The groups were compared using unpaired two-way t-tests. And the results I will be present in the next slides here. In terms of pups per litter, when we compare the cage control relative humidity, the black bar, where the humidity was between 55 and 70% during the study period, to the room control relative humidity with the relative humidity between 34 to 60 to 76% during the period, we saw that the ScanClimb group had significant more pups per litter when compared to the room control relative humidity group. And as mentioned in the introduction to this study, this was done on various strains of mice, and we also tried to look into just the C57 Black 6 strains, comparing these, and we saw a significant difference when we compared the ScanClimb control relative humidity, the black bar again, to the room control relative humidity. A smaller difference, but still a significant difference between the 2 groups. We also compared the pre-weaning mortality. Here we did not find any significant difference in pre-weaning mortality between the ScanClimb control group and the group where relative humidity was controlled on room level. However, we also investigated the total litter loss, and compared this between the two groups, and we actually saw a 30% difference, with 30% more total litters being lost in the group housed at room-controlled relative humidity. So here we see an indication of more pups or a significant difference in more pups per litter being born, and also significantly less total litters being lost when the animals were housed in the ScanClimb system. As I mentioned in the summary from the last webinar, it's of course also very interesting to look into how the variation in relative humidity can affect these outcomes of breeding performance. And on this graph, we tried to compare the standard deviation of relative humidity in the first week after birth. We compared it to the average, which is stated as the expected total litter loss in this figure. And we divided the standard deviations into a low standard deviation, an intermediate standard deviation, and a high standard deviation. And as you can see from this, with a low variation or standard deviation of relative humidity, we saw significantly less total litters being lost when we compared it to the expected numbers of litters being lost. And with the high standard deviation, we saw significant more total litters being lost when compared to the expected. So this indicates that the variation in relative humidity can affect the survival of total litters in the first week after birth. Of course, it could be very interesting to investigate how the fluctuations in relative humidity affects the breeding performance even further, having studies with a controlled fluctuating pattern of relative humidity compared to a steady controlled relative humidity. This is also something that we would very much like to start studies in. I have mentioned all these limitations during the presentation of the studies. I would just like to emphasize that, of course, we have some limitations to the study. The model of ScanClimb we used for the experiment is a model only for humidification. Of course, it would be very interesting also to make studies with a model that could dehumidify, having a steady control of relative humidity all through the period and not having the relative humidity rise above, for example, the 55%, as we set the ScanClimb to in this study. Then I mentioned that the groups were housed in different rooms, and of course other factors could affect the study outcome. Of course, we tried to eliminate these factors, but it would be very interesting to look into studies of breeding performance in the same room. And then also only look into one particular strain of mice, not having various mice strains as in this study. And we have actually an ongoing study looking into breeding performance of one particular strain of mice in the same room. So we are collecting data at the moment to get an indication that we can still see this difference in breeding performance when having eliminated these limitations. The results that I just presented have been presented as a poster as well at conferences and meetings, and the poster is available on our website. And just to conclude, what we have found is our results, they strongly suggest and actually show significant difference in breeding performance of mice when we have a control of relative humidity above 55%. The mice have more pups per litter, and significantly fewer total litters are lost pre-weaning when we compare to the animals housed at room-controlled relative humidity. Of course, further investigation is warranted, as I have mentioned, especially in the last slide. Comparing the data to another study that I presented at the last webinar would be interesting. This is a study from Turku and Finland, where they also had a large-scale breeding study. Here they saw a difference in pre-weaning mortality. So they saw a lower pre-weaning mortality when the animals were housed in the ScanClimb system, both looking into a whole year of data collection and also looking into the winter months where the humidity is lower in the room. This is different from the study that I just presented, where we did not see a difference in pre-weaning mortality, but we saw more pups per litter and fewer total litters lost. And this is also an indication that perhaps the strain of mice could have an effect on the outcome of these studies, but definitely it emphasizes that we see a better breeding performance of mice housed under controlled relative humidity. The data from the Turco study is also presented as a poster, which you can find on our website. And the conclusion from the study is that tight control of relative humidity leads to significantly lower pre-weaning mortality. Of course, other factors can also influence the pre-weaning mortality. But that was it for me in terms of the study from King's College. And now I will give over the word to Stuart. I would like to thank Stephen Woodley and the staff involved from King's College. And as mentioned at the beginning, I will take questions in the end of the presentation. But thank you very much for listening to this first part.
Okay, good morning. Thanks for the invitation to speak today. So I wanted to talk about the study that I conducted whilst I was at King's College London, looking at the impact of humidity on embryo transfer success. So over the next few minutes, I'll give a little bit of background information on embryo transfers, go into a little bit of technical detail about how we conducted the study, the results that we had, and then what conclusions we can draw from the work, if any. So at King's, we're doing quite a lot of embryo transfers for rederivation projects of entire facilities, and also as a standard introduction route for most mouse lines into our facilities. So embryo transfers are a fairly key part of our work. It involves surgically introducing embryos into the reproductive tracts of a mouse. These mice have been rendered pseudo-pregnant, so they've been mated with a sterile male. They've been plug checked, and we need to implant the embryos, or the stage of the embryos need to match the stage of the female that's going to have them implanted in her. Interestingly, you can put later stage pre-implantation embryos back into a 0.5 days post-coitum plugged female. So that's the as soon as she's plugged. And we found that our surgical route was optimal. There are other methods available for embryo transfer, including a non-surgical route. However, there's quite a significant drop-off in the viability of the embryos as you culture them towards a point at which they can be implanted in the uterus using a catheter. So we've stuck to the surgical route. On the right-hand side, you can see, or on the right-hand side of this slide, you can see an image, just to give you an idea of where this embryo transfer is happening. The ovary, oviduct, and uterus are exposed along a midline incision into the mouse. And on the top right, you can actually see a picture. So you've got the uterus, the oviduct, and then the ovary. And on the bottom right, in the red circle, there's some air bubbles. So we actually place the air bubbles behind our embryos when they're implanted. So if you can see the embryos flowing through the oviduct, then you know that your embryos are in front of that. And we consider that a successful transfer. So for the study, we tried to keep the criteria fairly tight. We only used IVF generated embryos, so we were generating some embryos by naturally mated or from naturally mated mice, and there are also some cryopreserved embryos that we'd use very frequently, but we've just stuck to the IVF generated ones for now. Roughly 15 embryos were implanted unilaterally, so into one of the oviducts out of the two available. We use different genetic backgrounds. So for our rederivation projects, there's quite a range basically. So yes, there's quite a lot of the black 6 substrains, but there was also mixed, or mice from a mixed genetic background too. All of our recipients were CD1 females at 0.5 DPC. For this study, all the transfers were completed by one person to reduce the variability between technicians. And as part of the study, we also looked at whether or not we saw better success from singly housing or from co-housing recipients. As an aid to the study, we also conducted some nest scoring. So you can see the scoring criteria at the bottom of the slide. This was conducted on a weekly basis. It was fairly subjective, but due to the few room technicians that were available, I think it worked quite well. It's worth noting as well that the room that we used, we only used one room to house the two groups of mice that we're looking at. So in order to maintain consistency, so for environmental enrichment, technician, light, temperature, we used this single room. So there was one rack for the scan climb controlled group and one rack under the room humidity control. Our recipients were randomly attributed to either group, and you can see that the room was around 45% RH, and the scan climbs were set to 55%. So over the process of the study, we had our humidity sensors, temperature sensors, and you can see the temperature was very consistent across both, as we'd expect, because they're in the same room. We saw significant spikes in the building controlled humidity, and because it was the scan climb that didn't dehumidify, there are also spikes at similar time points as you would expect, but otherwise very consistent humidity. We can also have a quick look at the nest scoring. We didn't really see any noticeable difference in the nest scores with each group, but I think it was quite a nice exercise in itself just to review the nest scoring. So in terms of the results of the study, here's a few sort of readouts that we have. So on the top left graph, you can see we're pretty consistent with the number of embryos that were transferred into each recipient. So it was about 15 for the 4 groups. So room paired, room single, scan climb pair, scan climb single. On the top right, you can see the number of pups per recipient varied somewhat through the room and scan climb groups, with the scan climb single occupancy having the highest number of pups per mouse born. It is worth noting though that the variation is quite large. So this is just worth bearing in mind. On the bottom left, we can have a look at the recovery rate almost as a percentage. So again, we see the scan climb performing better. So this is the 55% relative humidity over the 45% group. And again, having the recipients housed singly seems to have given us the best recovery rate. And then bottom right, we've got the humidification method of control only. So we're not looking at single or paired occupancy. And you can see that the 55% relative humidity group had a higher number of pumps borne or higher recovery rate. It's worth noting that the group that was under the room humidification with only single occupancy, there's only one cage in this group, so there's no error bars. So the results look quite compelling, I think, so far. From a statistical perspective, there's no significance of the humidity on the recovery rate, but it's very close. And that's the same for both, I guess, the humidity, but also looking at the genetic background and the single or group housing. So our next steps are to get some more data. Pet medics are generating a transgenic platform. We're currently performing a lot of embryo transfers, and so it would be great to conduct a little bit more work. And I think with a few more numbers, we might be able to see a statistical significance between 45% and 55% humidity or higher. Interestingly, around the time that we were conducting this work, the UK Code of Practice was under review, and there were some questions being raised about the significance of relative humidity and whether or not this is worth monitoring. And I think what we've seen so far is that it definitely is worth stipulating a range. I think it's important to acknowledge the biological services unit staff in New Hunt's House, particularly Tolga and Stephanie, who were the primary technicians in that room, and also the genome editing and embryology core. So I'm happy to take any question.
Yes, thank you very much, Stuart, for an interesting presentation. I will just shortly be rounding off, and then you can just write the questions in the chat room in the meanwhile. I will round off with the slide I also showed you in the beginning. These effects that we see on breeding performance and also indications on improvement in embryo transfer, they of course have some 3R aspects, as we could perhaps lower the number of animals we use for breeding and also for embryo transfers. And it could also have, with the data from the last time, it could also have some impact on the reproducibility of research if we have an effect of this variable humidity on our research results. But I think we have gone a little bit over time, so I will stop for now and open up for questions. I hope you have some interesting questions for the topic, and thank you again, Stuart, for your presentation.
No problem.
Okay, no questions yet, but I actually, you looked into the nest scoring and you did not see any differences, but I actually think this is a quite interesting parameter, especially because we see quite high relative humidity in nests of mice. So having this control of relative humidity, and especially in cases where we have a low, very low relative humidity in the room. Here you have 45. That's not very low. Sometimes we see very much lower relative humidities in room. Here we could perhaps see a difference in the nest scoring, and I think that is also something that I have planned to look further into in our future studies.
Yeah, so just to add on that, I think the scoring was really quite subjective and is obviously very much dependent on the enrichment that's in the cage. I think some bedding material is a lot easier for the mice to make nests from than other types. But yeah, it is certainly an interesting factor to look at.
Yeah, and especially because many people are using the nest scoring in their behavioral studies and so on. So of course it's very interesting to see if we have these other factors than the study parameters influencing the outcomes of these studies. But it doesn't seem like any questions are ticking into the chat room. Of course, you are always welcome to contact us afterwards, email us, give us a call if you have any questions. Otherwise, I'll just thank you all for participating and hope to see you in a webinar sometime soon. Have a great day.